function. Basically, gamma function is one kind of integral, one special type of integral. It is also known as one kind of special function. So, what integrals is known as gamma function? Just see here, gamma of n. This notation just seems to be opposite of n. This function is known as gamma. So we can say like this, gamma of n is equal to, this is a definite integral, limit goes from 0 to infinity, e to the power minus of x to the power n minus 1 dx, where n is greater than 0, means n is always a positive integer. So this integral, this special integral is given value is gamma of n, or is known as gamma function. Gamma function is basically Euler integral of second kind. If you studied theory in the books, you can find that only. So there are many form of gamma function, some properties. First, you have to learn this integral, then with the help of this gamma function or this integral, we can solve many integrals very easily with the help of this gamma. So you have to memorize this, what is gamma n is equal to 0 to infinity e to the power minus of x to the power n minus 1 dx. One another way, if we put at the place this x, put x is equal to t square, then another form of gamma function is 0 to infinity e to the power 2 e to the power minus of x square x to the power 2n minus 1 dx. Means I put x is equal to t square, when we derive, replace again t in terms of x. So that is one another form of gamma function. Either you write this or this, both integral gives value of gamma n. Now I will give you some properties of gamma function. Then we discuss some integrals or some problems how to derive gamma function. 1. First property of gamma function is gamma n plus 1 is equal to gamma of gamma n. Okay, so how it comes? If you write gamma n plus 1, it means our integral is 0 to infinity e to the power minus x to the power n minus 1. X to the power n minus 1. So n is our n plus 1. So n plus 1 minus 1, n plus 1 minus 1. So cancel x to the power n dx. Now we have to integrate this with the help of integration by parts. You have formula integration of uv dv, that we have to use integration by parts. So what results comes here? Result is minus e to the power minus x to the power n, limit going from 0 to infinity, minus 0 to integral 0 to infinity minus e to the power minus x and x to the power n minus 1 dx. So this terms becomes 0 when we apply the limits 0 and infinity, because x0 is 0, x infinity is also gives 0. So this term terminates and this terms gives this minus and minus combined, it will be plus e to the power x to the power n minus 1. So n is the constant, taking outside, integral of 0 to infinity e to the power minus x to the power n minus 1 dx. It means what is this? Yes, gamma n. So it becomes n of gamma n. Means gamma of n plus 1 is equal to n of gamma n. It means if I write gamma of 4. So gamma of 4 is n plus 1. So our n is 3 plus 1. So it equal to 3 gamma 3. Again 3 gamma 3 is 2 gamma of 2. Again 2 gamma 2 is 1 gamma of 1, and you should always remember gamma of 1 equal to 1. So it is 3 into 2 into 1. It means factorial 3. This is one another important property, that gamma of n plus 1 is equal to factorial of n. Second property. First is gamma of n plus 1 is n gamma n, or we can say gamma of n plus 1 is equal to factorial n. Factorial gamma of n is equal to gamma of n plus 1 upon this n, where n is negative integer. If sometimes n gives negative integers, then you can use this formula, gamma n is equal to gamma of n plus 1 divided by n. You can find the result, you can find the solution. Fourth one is n gamma of 1 minus n gives pi upon sine of n pi. This property is also we have to use in many integrals when we solving the integrals. Sometimes we may coming in this condition, then we directly substitute n, gamma of n into gamma of 1 minus n is equal to pi upon sine n pi. Last one is the value of gamma of half, gamma of 1 by 2. Fifth property, number 5th. That gamma of 1 by 2 gives under root of pi. Sometimes they ask about the proof of this gamma half is equal to root of pi, how it will be coming. So I can show you gamma half. If we write proof 1 by 2, if we write in the integral form, 0 to infinity e to the power minus x. Okay, so we write second form of this, whatever I give you, 0 to infinity e to the power minus x square, x to the power 2n minus 1. So 2 into n is 1 by 2 minus 1 means x to the power, this gives x to the power 0. X to the power 0 means 1. So our integrals become 2 times 0 to infinity e to the power minus x square dx. Clear? Now if we multiply one more gamma here, so gamma 1 by 2 into gamma 1 by 2, again one time we have to write same formula in another variable, 0 to infinity e to the power minus y square d of y. Means same things, in this case we took variable x, in this case we took variable y. Then gamma 1 by 2 is this. Both if we combine the constant, 4 0 to infinity, it becomes double integral e to the power minus x square plus y square dx dy. Clear? Up to here, very easy, very simple. Now for proof gamma half is equal to root pi, we have to substitute this x and y in polar coordinates, polar form. You know, always we discuss about the polar, means we have to convert this into r and theta. So this integrals we convert into r and theta. So substitute x is equal to r cos theta, y is equal to r sin theta. What? X is equal to r cos theta, y is equal to r sin theta. Clear? If x is equal to r cos theta, y is equal to r sin theta, and dx by dy is equal to r d theta, dr by d theta, you can solve it with the help of Jacobians also, or you should remember these terms. One more thing, if we divide, we want to find out y by x is sin theta by cos is what? That is tan theta. Yes. So tan theta is y by x. Or we can say theta is equal to tan inverse of y by x. We find value of theta because when we convert this integral in r and theta, we have to find out the limits of in terms of r also in terms of theta. So for theta we can solve this, and for r, if we square in these two equations, x square is equal to r square cos square theta, y square is equal to r square sin square, and adding x square plus y square is equal to r square sin square theta plus cos square theta. Definitely you know sin square plus cos square is equal to 1. Very good. Then our x square plus y square equal to r square. So for finding the limits in terms of r, we use this equation. For finding the limits in terms of theta, we use this equations. So now last thing, finding the limits in terms of r and theta. When x is equal to 0 and y is equal to 0, tan inverse 0. So theta is also 0. Similarly, when x is equal to infinite, y is equal, means tan inverse infinite. So tan inverse infinite is equal to pi by 2. Hence, limit for theta is goes from 0 to pi by 2. Second, x square plus y square is 0. When x and y are 0, r is 0. When x and y is infinity, r is also infinity. Hence, limit for r is equal to going from 0 to infinity. So now we convert this complete integral in polar form by substitute these things. I think you better understand how transform the limit and the coordinates. So our integral become 4, 0 to pi by 2, 0 to infinity e to the power minus r square dx dy is equal to r dr d of theta. Now last step, we have to solve the given integral. What is the next step? We have to solve the given integral. So our integrals become 4, 0 to pi by 2 d theta. Yes, theta separate, then 0 to infinity e to the power minus r square r dr. Okay, this d theta is theta. If we want to solve this integral, just put r square is equal to t, 2r dr is equal to dt, means r dr is dt by 2. Similar, if we put here e to the power minus t dt 1 by 2. So it gives 1 by 2 minus of e to the power minus t means minus r square. So our integral. Substitute here 4 theta 0 to pi by 2 minus of 1 by 2 e to the power minus r square 0 to infinity. Is this clear? We substitute here. Next step, just simplify. Minus of 2, this gives pi by 2, this gives e to the power infinite minus e to the power 0, means this gives 0, e to the power 0 is 1. So our answer is pi. Clear? It means gamma of 1 by 2 into